7.0.0.1, or presumably at localhost. Here at localhost, we have our app. So it's just the Python code is running in my IDE, like all Python applications run. Pretty normal, standard stuff. Turn that off, and we'll just take a look at the Docker file here. It's weird, never seen that tag before. Cool, they're helping you know who you can email for problems, I guess. I probably wouldn't put this on my stuff. I don't need people sending me emails. But yeah, so this is a Docker file, and you can think of this as a script which builds the container. So this Docker file inherits from a parent Docker file, and that is the Python 3.6 Docker file. You'll find on Docker Hub. Let's go to Docker Hub. You'll find that there is an insane quantity of Python images available on Docker Hub, and this is the image that we're looking at specifically, the Python Docker image. There are tags. There's a Python 3.9, 3.916. We can scroll. There's over 10 pages of Python-related Docker images. You can find a Docker image for just about anything these days, and this Docker Hub landing page will kind of explain to you what this Docker image is doing and what it's for. So you can see certain things that it supports, and I don't know if you can actually see the file that was used to build this image. Sometimes that's referenced here also in a GitHub. But basically what's happening is this is giving you a base to build on top of, the from Python 3.16. And then you can do whatever you want in the context of this Docker image. So this is already a Linux. I'm guessing it's Alpine Linux, but I don't actually know. It's a Linux operating system that has a Python 3.16 install on it, and that's all it has on it. So if you connect to this, if you SSH into this thing, or you connect to it and start executing lines at command line, you'll have trouble doing anything other than Python because it's a minimalist implementation. So starting from here, now we're doing all these things. We're building these things on top of it. We're letting people know who we are on line 2, and then we're copying the directory. Dot is just a reference to the current directory that we're in, over to the /app directory inside the container. And we're setting the working directory inside the container to the /app directory. Then we are running pip install, and we always do things in the context of the working directory. So we're inside /app running pip install /requirements.txt to install our Flask. Whatever the latest version of Flask is what it's going to install. And then we have an entry point and a command, which is violation of Docker standards. You're supposed to have either an entry point or a command, but whatever. We'll forgive this application for doing that. So the entry point and the command are basically saying this is how this is what you're supposed to do when you start running. The image will build, and then the image, if the image stops building and it has no commands or entry points, it won't do anything. It won't start up. It won't run anything. So for us to actually turn this on, we're going to use a. Let's go back to this application. Any questions about what this file is and what it's supposed to be doing before I actually execute it?
So you were saying that it should be entry point and then CMD would be on the same line, or should CMD have come first?
Probably it should just be something like this. That's probably what it should be, or alternatively, that. But I don't want to mess with it because I think this thing works, and I don't want, since we're like in the middle of explaining this stuff, I don't want to like break it and then have to debug it. So I'm pretty sure that if I remove entry point and I just put Python in front of this, it'll just work. But that's for another time. Something that's pretty commonly done with Docker images is to have no command and no entry point. You don't specify to the Docker image what it should be doing, and it's at runtime that you pass those in. Mm-hmm. So, for example, if we look at this, well, this doesn't do that. But this isn't doing it either. If we were to do docker run and then type out a command.py, this won't work. But in the context of the fully qualified command, you would basically execute a specific command. And it's common in the context of Docker images to pass the command at runtime rather than to specify it in code. And by doing it that way, you make the Docker image a bit more flexible. Like it can do multiple things. It just depends on how.
Is there any way to comment in, like the command line, what you should be putting in, so you can like copy that and then Control V it on the CMD?
People commonly use READMEs for that. Like the README will commonly have the commands, but if you're just looking to copy paste commands, but the way to actually do it is to build a Docker Compose file, which I'll get into after we've seen the basics of Docker. Docker Compose is like another level of complexity on top of Docker. Any other questions about this file and what it's doing before I actually try to build the image and run it? Okay. I'm going to build it. So this is a command to build this image. And all this is saying is build me something and tag it with this name. So that's the name that the image will have tagged to it for reference in the future. And I want you to build the thing in the directory that I run this command. That's what the dot is. That's a relative path. And it's basically just it's gonna look in the current directory for a Docker file, and it'll run it, and it'll assign this tag to it. So that's what we're gonna do. Building. Installing pip requirements. All right, so we can see that it went through step by step the Docker image. It didn't print out the maintainer's name, which is fine. We don't really need that. It copied the current directory into /app, set the working directory to app, installed the pip requirements, and it exported an image. So now we have an image with this name, whatever name we tagged it with, which is sitting on our computer. And it is an encapsulated version of this application. So if we want to actually do something with that image, here's an example of doing something with it, Docker run, and then we reference the tag that we gave it. And in this case, Docker run is also doing -p, which is assigning a port. This is mapping your host port 5000 to the port 5000 of the container. So that means that if somebody hits your computer's port 5000, it will route that into the container's port 5000. We want that because the Python application is listening on port 5000. Make sense? All right, I'm gonna actually run this. Okay, and then -d means detached, run detached. So it's running, and we can see it here running. The app came up. This is the command that the app received, and these are the ports that are mapped. My local port 5000 is mapped to port 5000 inside the image. So if we now go to localhost 5000, boop, we get the thing again. It's happening. So the app is running inside the Docker container. If I were to bring the Docker container down, Docker container, then the Docker container is gone, and I don't have anything at port 5000 anymore. We could also alternatively no, I'm sorry. I'm trying to change the port. I don't use this terminal that often, so I'm not used to it. Docker.
I'm having a hard time seeing that.
Oh, right. It's all tiny. Right. I forgot about that. I have no idea how to change the font on this thing. Maybe wheel up? Nope. Man, wheel up? Nope. Increase font size.
A lot of terminals and IDEs use control wheel up. But
yeah, I've been trying that, but it's just
okay.
It's just not happening. Is that better?
Enough.
Thank you. Yeah, I can read that now.
Okay. So yeah, I'm just going to change the port. So I'm going to expose it on port 9001. So my host port 9001 is mapped to the Docker containers port 5000. So that means when some request goes to my computer's port 9001, it'll get routed into the container at port 5000. So what is the effect of that? Let's run the thing, make sure it's running, and it is. That means if I hit localhost 5000 here on my host machine, nothing happens. But if I hit port 9001, it routes it into the container, and we have Flask inside Docker. Yay! So this, I realized that we just went through a lot, but basically all that we went through here is sort of the entirety of getting the simple steps of getting a Python application like this inside of a Docker image. These steps don't change that much, even if your application is extremely complex. The things that tend to change is you might have a couple other commands you're going to run here in your Docker file, because maybe I don't know, if you're running, say, let's say you're trying to run Stable Diffusion or a machine learning thing, then you might need some system level packages, things that you're not going to get through pip, right? And those things you would set here, right? You'd be like run, apt-get install whatever packages you want to install. So if your system needs to be configured beyond a simple boilerplate template, then you do that here in Docker, the Docker image. And that's kind of all there is to it. I can go on and talk about Docker Compose, but I've already gone over a lot of complexity. So are there any questions about what I've talked about so far?
I have a question, and I just didn't see where they set that 5000 in Docker for the port. Do you mind just showing that to me real quick? I'm sorry.
No
okay,
problem.
thank
so
you.
This,
Appreciate it.
This is the app. The app is listening on port 5000 here.
Yeah. Thank you.
But this isn't telling Docker to listen on port 5000. This is just saying that the Flask app is listening on port 5000. That means within the container, when this is running, it'll be listening on the container's port 5000. What I did in my command line is, let me kill this application again.
Yeah, he told the command line to listen to port 5000.
Yeah, I saw that part.
So here, when I actually brought the Docker image up, I bound my host port into the containers port, which is just routing traffic. To make it simpler, I could have just done this. This would be less confusing. So this line is binding my host port 5000 to the containers port 5000. When working with Docker, it's important to recognize that the container is its own computer in all senses of the word. It has its own IP tables. It has all its own ports. It has its own threads and processing. It shares the computational resources of your host machine, but it is really an isolated machine. So you have to, if you want to interact with it, you have to hook into it. And this is how you hook ports into it. It's also possible to mount volumes, all the other stuff that you would normally do with networked computers.
So if it has its own IP, is it doing everything through a proxy?
Docker will establish what's called a Docker network, and it will in fact create its own networking inside that Docker network, but it won't expose. It's not going to talk to your router or your DNS host like in your local area network and get an IP assigned. From the perspective of your local network, the local network's not aware that Docker's there. This routing the Docker networking routing is happening within the context of your host. Mm-hmm. So that's why if somebody were to say, put in my IP address here, this is a good example of what's going to happen. Let's just run this. And I don't know what my IP is. What's my IP? Is it ifconfig on this? Where is my IP? There's my IP, I think. Pretty sure. So if I were to go to my IP address and then that port, then it works. So I did this on this machine because you people can see this machine. But if you were on another machine on the network and you used this route, it would work. And that's because my computer has bound my port 5000 to the port 5000 of the container. So it's routing traffic that way, if that makes sense. Mm-hmm. You can bind an arbitrary number of ports. I've had containers in which I've bound a dozen ports. For example, I have a Firebase Docker Compose, which spins up the Firebase services for local development purposes. And it has to expose like 12 ports because there's so many Firebase services.
That's pretty cool.
Other questions about how this Flask application is operating inside of the context of a Docker image, what Docker images are? Any questions about any of this stuff that we've gone over?
Can you make it so that someone off of the network can connect to it?
What do you mean exactly by that?
Like if I go to a tech meeting somewhere, is there some way that I can, without using something like TeamViewer or No Machine, remote into that environment?
Yeah, well, not without any network access, because without network access, you can't communicate with it. So if you wanted, let's say I wanted you folks to be able to hit this right now, then what I would have to do is expose this port of this machine to the internet. So I'd have to go onto my router and specify like an IP forwarding rule, which forwards any requests to whatever is inbound to this IP address and this port. And then, yeah. So you don't have to worry about that stuff if you're installing this in environments that are intended to like host Docker images, for example, EC2 on AWS. They're just going to give you the IP address it's on, and it's going to be directly exposed to the internet. And it's up to you to manage it to not get it attacked by, horrible people.
Makes sense. Thanks.
Mm-hmm. Let's see if I can ask the question in a little bit different way. Let's see. Can there be two applications in the Docker container, and can one of them be SSH?
Yes, Docker containers. Again, earlier I mentioned that Docker containers are their own operating systems. That means you can do anything. They're their own computers with their own operating system. You can do anything on them that you could do on any other computer which is running that particular operating system. If you use Alpine Linux as a base, anything you can do on Alpine Linux, you can do in that container. If you use Debian or Ubuntu, sometimes I've used Ubuntu as a base for Docker images. Anything that you can do in Ubuntu, which is a lot of things, can be done on that Docker image. You can run an arbitrary number of processes. You're constrained by the computational resources that the machine has, but there is no. It is a computer, and you can do whatever you want to it.
What
Does
if
that
you
answer?
want to use Windows? Do you need some kind of pay somewhere to get permission to use it, or
So you're a little quiet. Would you mind asking that again?
what if are you using something that licensed and not free?
As a base for the image?
Yeah.
Right, like you're using Windows as a base for a Docker image?
Yeah.
So I've never observed anyone use anything other than Linux as a base for a Docker image. However, it is technically possible to do that. I don't know how to do that. I would expect that what you would do is something along the lines of from Windows and probably, oh, hey, that is actually sweet. Yeah, I'm using GitHub Copilot, and it just auto filled in an actual Windows image. Copilot's kind of cool. Anyway, that is an actual Windows image. I don't know how this would run. I'm guessing you'd have to set an environment variable that's like the license key or something like that. But I don't know. Like I said, I've never attempted to use anything other than Linux for Docker images. I could see why you might be concerned about something like that if you were a .NET developer. But if you are not a .NET developer, if you develop in any other paradigm, I would strongly recommend using Linux as your base rather than Windows.
Can you have it set up multiple images? Like if I wanted to have two people on the same file on my computer and I wanted to do it automatically, could it somehow make it so that whenever they connect to my computer, it can just create another desktop environment?
Let me ask some questions here. So when you say you want to have two people on your computer, what do you mean by that exactly?
So maybe by like, not so much as a user, because I realized Docker doesn't work like that. But if I wanted someone to work on a project on my computer with an entire environment, could they say, oh, okay, so I want to get onto this Docker image, and there's not one currently running, so it just runs one of the images, and then somebody else connects, and they want to use that same image, so it makes another image?
Yeah, what you're thinking of is more like a virtual machine. So you'd want to probably use virtual machines for the use case that you're describing. And you're describing a user who's connecting sort of to a GUI environment, right? Like a Windows environment or an Ubuntu environment with an actual interface.
Yes.
And they're looking to do some stuff. Maybe they're using Google Docs, or maybe they're playing Minecraft or whatever. They're doing some stuff in that environment.
Correct.
Docker's not good for that.
Okay.
You could accomplish that with Docker, but I wouldn't recommend it. Docker's main purpose is to act as like a container for a specific task in a headless fashion. It would be very unusual to have a head when you were working with a Docker image. If you're doing anything like headfully, you're probably in the virtual machine world rather than the Docker world.
So
Docker images are stateless. It is important to recognize. So if I were to do things in this Docker image and then bring it down, bring it back up, all those things I did are no longer done. So if you're looking for, a long-running stateful environment to do stuff in, virtual machines, not Docker images.
So then by doing the port forwarding and all that, could you run a Docker image as kind of like a service as a software?
Well, if you mean do Docker images act and wrap services commonly, yes. That's how services are normally deployed. So for example, a better example would be, let me open my Portainer interface here. Okay, so there's a lot of complexity here, and I won't go into it. But I have a lot of layers of complexity built on top of Docker here, which if you get into Docker, these are common things that you end up doing. So if we look at, this is a server that's running in my home lab, and this server is running a number of stacks. And these stacks are collections of Docker images, each of which does something. So in the example of, I don't know, the R stack is probably the best. Let me go look at this one, Synology, and then the R stack. The R stack contains, there are 1, 2, 3, 4, 5, 6, there's 7 Docker images, which are all active in this group that's just colloquially called a stack. And they're all doing something different. This one is exposing the sonar service. This is the readar service, radar service, qubit torrent service, prowler service, LiDAR service. And this is something I was messing around with that is not, it's not doing anything, basically. It doesn't work. But these ones are all distinct services. And that's normally what you do with Docker is each Docker image is normally acting to expose one service. It complies with the microservice architecture design philosophy. So you're usually not hosting many services on a single Docker image. You're usually making many images to host many services, but that's not necessarily the case. You can host many services on an image. For example, if we look at this is an open source Firebase Docker Compose I created. Docker Compose. There's just one image here, Firebase image, and I'm exposing lots of ports, and that's because there are this many services. Each of these ports maps to a service inside the Docker image. And I'm doing it this way because I have to do it this way because that's the way the Firebase emulator image works. I didn't build this image. I'm taking it from Google. But they built an image that contains 1, 2, 3, 4, 5, 6, 7, like 8 services, and I've mapped a port right from my host to each one of them. So you can do whatever you like, but normally people create like a distinct Docker image for each service that they're running. The overhead of each Docker image is very low, especially if you're using minimalist images. It can be as low as like 50 megabytes, 100 megabytes of space and memory.
I think the base Alpine is only like 6 megabytes, right?
Yeah, but whatever you're putting on it will take up space. It just depends on
Right.
just depends on like what you're doing, how much space it is. But whether it's 6 megabytes or 100 megabytes for most systems, it doesn't really matter.
Pretty great. Thank you.
Yeah, no problem. Other questions? So I can talk about Docker Compose, but we might want to save that for next week or another time because we've already been speaking for a bit and we've already gone through a lot of complexity, and it can be difficult to assimilate large amounts of complexity all at once. Does anyone have an opinion on whether they'd be interested in looking at Docker Compose right now, or whether you'd rather talk about it another time?
Have it be next week. If
Yeah,
that's
that sounds
okay
good.
with other people.
Yeah.
Yeah,
Yeah,
that
no
was
problem.
great. Thanks a lot.
Yeah, that was really helpful.